Hello everyone, I am Abarna, Assistant Professor in the Department of Artificial Intelligence and Data Science at Vellalar College of Engineering and Technology. We are going to learn about Exploratory Data Analysis, is also known as EDA. EDA. EDA is the most important step in data analysis. It helps to understand the dataset by summarizing the main characteristics and use visualization methods such as charts and graphs to find patterns, trends, and problems in the dataset. It was mainly used by data scientists. EDA mainly focus on understanding your dataset, finding patterns, cleaning the data, preparing it before building models. For example, imagine you are analyzing a student marks. Some marks are missing, some values are repeated, some values look wrong. So predicting results, you need to clean the data. That is called EDA. To clean the data, there are several methods. The most important method is data transformation. Data transformation techniques consist of several methods. The first method is performing data deduplication. Deduplication means it contains duplicate rows. Removing them is essential to enhance the quality of the data. For example, here import pandas as PD. Here we use a library function as pandas. We insert a data frame consist of variable name and marks. Name consists of A, B, C, A and marks consist of 90, 85, 88, 90. Here the data frame, we need to check whether it consists of duplicate elements. If it consists, we need to remove them. These are the two conditions in data deduplication. We need to find the elements are duplicated or not. So the syntax is df dot duplicated. If it contains duplicated, we need to remove them. The syntax is drop dot duplicates. To remove duplicates, drop dot duplicates. We need to find the duplicates. It's df dot duplicates. For example, they consist of frame 1. Frame 1 consists of two different columns. That is column 1 and column 2. Here consists the values such as looping 10, looping 10, looping 22, functions 23, functions 23, functions 24 and functions 24. We need to find whether it is a duplicate or original element. The syntax is df dot duplicate. The output will be in the form of boolean. So we need to check the frame 1. Frame 1 dot duplicate. So first one is looping 10. Looping 10 is a original element. So it is not a duplicate. So the condition is false. Next looping 10. Looping 10 is a repeated element. So the duplicate element is condition is true. Next looping 22. Looping 22 is a original element. So it is not a duplicate. So the condition is false. Next function 23. Functions 23 is a original element. It is not a duplicate element. So the condition is false. Functions 23. Functions 23 is a duplicate element. So the condition is true. Functions 24 is a original element. It is not a duplicate element. So the condition is false. Next function 24. Function 24 is a duplicate element. So the condition is true. After finding a duplicate elements, we need to drop them. So the syntax is frame1 dot drop dot duplicates. After dropping the duplicate elements, the originality elements will be displayed. Looping 10, looping 22, functions 23 and functions 24. This is called data deduplication. Next, handling missing values. Handling missing values are represented as NaN values. That indicates there is no specified value in the particular index. Reasons for missing values: incomplete values in the data set, some values are not matched, missing values due to data collection errors, reindexing of data can be resulted in the incomplete data. Let us see here. Here data frame consists of two different variables. First one is store1, another one is store2. Store1 consists of some values and also a NaN values. Store to consist of values and also a NaN values. NaN values means missing values. We need to check whether the data frame consists of null values or not. So the syntax is null. It shows the output in the Boolean format, whether it is a true or false. Consist means true. Either no non values means false. Next, we need to add the NaN values. Is null dot sum. It counts the NaN values per column. Is null dot sum. Next, we need to find total NaN values presented in the data set. The syntax is null dot sum dot sum. Is null means identify missing values. Sum means count to the missing values. Filling missing values. How to fill the missing values? Because NaN values has no value, we replace the NaN values instead of 0, because 0 does not affect the statistics including right, mean, sum, median. So we are replacing 0 for statistics for calculating mean, sum and median. For filling missing values, we use syntax as fillna.0. Fillna0 means where there is a NaN value, it fills the, instead of NaN value, it fills 0. So we use fillna.0. Next method is backward and forward filling. This is a NaN values can be filled based on the last known values. It consists of two methods. First one is forward filling, another one is backward filling. Forward filling is mentioned as F fill. Backward filling is B dot fill. Here fill now, we need to fill the data. So we using fill now. Method is equal to whether it is a forward filling or backward filling. First we use forward filling. Here apple value is 20. Banana is a NaN value, kiwi NaN value, grape NaN value. So we need to fill this value. The forward filling means first one is apple. Apple value is 20. Okay, it has value. We need to insert the value. Next banana. Banana consists of NaN values. So we need to check the before value. Forward filling. So the apple is 20. Apple is before the banana. So the banana value also 20. It copies the before value. Next kiwi. Kiwi is a NaN value. We need to check the before value. Before value is banana 20. So kiwi also 20. Next grape. Grape value is a NaN value. We need to check the before value. Before value is kiwi. Kiwi value is 20. So grape also 20. Next mango. Mango is consist of NaN values. We need to check the before value for forward filling. Grape value is 20. So mango value is 20. Next watermelon. Watermelon value is already given. The value is 18. We need not to fill any values. Next one is orange. Orange consists of NaN values. So in forward filling we need to see the before value. Before value is 18. So orange also 18. Next we move to backward filling. Fill now method is equal to, we use here b dot fill. B dot fill means backward dot fill. Okay, we need to fill by descending order. Okay, next here need to from last to first. We let's check. Orange is equal to NaN value, so we not fill any weather value because this is the last value. Next check the before value. Watermelon is equal to 18. Already it has value, so we need not to fill the value. Next mango dot equal to NaN values. Here backward filling, so the next value is watermelon. Watermelon value is 18, so mango is 18. Likewise grape checks mango values. Kiwi uses grapes values. Banana use kiwi values. Apple as it is, it consists of 20, so we need not to change any values. This is called backward filling and forward filling. Next, dropping missing values. Here from before we see how to find missing values, how to drop the missing values, and how to fill the missing values. Here we using dropping missing values. How to drop the missing values? Missing values such as NaN values. To drop the missing values, we use method as drop now. Just drop now method just returns a copy of the data frame by dropping the no rows with none. Where the rows consist none values, it entirely drops by using drop-now method. Drop-now method consists of two different by dropping by rows, dropping by columns. Dropping by rows means it drops the entire row that consists of NaN values. Let's see the first example. Here consists of list of fruits: apple, banana, kiwi, grape, mango, watermelon, and also oranges. The orange rows are removed because those rows, entire rows contains NaN values. The entire rows consist NaN values, so entire rows are dropped by how is equal to all method. If we need to drop by columns, the same method drop now how is equal to all, comma, the extra is axis equal to 1 means it indicates the column. So the store file consists of all NaN values. So all NaN values are deleted by axis equal to 1. So these two methods are used to drop the NaN values. Next, outlier detection. Outlier detection is very important in data transformation techniques because outlier data points are affect the statistical analysis and also does not give the perfect result. So outlier detection and filtering is very important. For example, the regular transaction is below 10,000, but suddenly he makes transaction for 1 lakh. This is called outlier. The unsimilar objects that away from the regular object is called outlier detection. This is called data transformation techniques that used in the exploratory data analysis to extract the good and quality of the data and eliminate unwanted missing values, deduplicated values, and outliers in the data set. And EDA is a very important technique in data analysis. After EDA process, we need to choose the model, and also after choosing the model, we predict the result. Thank you for watching.